Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Syahmi bin Muhammad Norfaizan. Now I want to present about my mini project of power electronics. The title is Analysis of DC to DC boost converter circuit. My member is Raja Danish Danial bin Raja Muhammad Ariffin and Muhammad Farif bin Mohamed Jasman. Next, introduction about a boost converter DC to DC. What is a DC to DC boost converter? A boost converter is a DC to DC switch mode power supply that is intended to boost or increase the input voltage of an unregulated DC supply to a stabilized higher output voltage. A boost converter relies on an inductor, diode, capacitor, and power switch regulate the power voltage. In a boost converter, the output voltage is varied by the max-phase ratio of the PWM signal to be equal to or above Vin. As power conserved, a boost converter that supplies triple the input voltage will only be able to supply one-third the current that it draw from the supply. However, boost converters are very popular in battery-powered devices, where perhaps a pair batteries deliver 3 volt but need to supply a 5 volt circuit. Okay, next, for pre-project boost converter operation, the figure show circuit when MOSFET switch on. The circuit action during the initial high period of the higher frequency square wave applied to the MOSFET gate at the start up. During this time, MOSFET conduct placing a short circuit from the right hand side of inductor to the negative input supply terminal. Therefore, a current flow between the positive and negative supply terminals throughout inductor, which store energy in the magnetic field. Okay, next, the circuit show when the MOSFET switch off. As the MOSFET is rapidly turned off, the sudden drop in current causes inductor to produce a back EMF in the opposite polarity to the voltage across inductor during the on period to keep current flowing. Now that there is no current path throughout the MOSFET forward bias at diode. For the last operation, when the MOSFET switch on back, current path-based MOSFET on. The MOSFET conduct the cathode of a diode in more positive than its anode due to the charge on capacitor. A diode is therefore turned off, so the output of the circuit is isolated from the input. However, the load continues to be supplied from the charge on capacitor. Although charge capacitor drains away throughout the load during this period. Capacitor is recharged each time the MOSFET switch off, so maintaining an almost steady output voltage across the load.
Assalamualaikum and hello everyone. My name is Mohamad Jasman. So this is our circuit for DC boost converter. So every component we had set is resistance is 50 ohm, capacitor is 100 microfarad, the inductor is 400 microhenry, the frequency is 40 kHz, the duty cycle is 0.4, and the input DC voltage we use is 50 volt. So we set the component current measurement is series with inductor to get the value of current DC circuit, and we set the component voltage measurement with parallel with resistor, capacitor, and DC voltage to get the answer of voltage in the circuit. So after we simulated the circuit, we get this data. This waveform is like that, and the maximum current is 3.435 ampere, and the minimum current value we get is 2.191 ampere.
Assalamualaikum. So moving on to the discussion, we can see that from the simulation, the output voltage shows a significant increase as it goes by. And the values that are obtained from the calculation are slightly different from the values obtained through the simulation, as this is normal due to the imperfections of the simulation system. And then the output voltage shows a low ripple waveform, and then there's some suggestions to reduce the ripples in the waveform are to increase the size of the capacitor, increase the frequency of the switching, and one more info is that MOSFET effectivity increases as switching speed increases. Then we can see the data that the comparison between the stimulated value and calculated value. Then here we have the differences aren't that very big, but you can see that it's quite close to the data obtained. And with that, the conclusion of the experiment is that we are all able to identify the purpose and the functionality of a boost converter, and we are also able to apply the formulas and equations into the calculation of the data. Besides that, we are also able to master the usage of the Simulink from the MATLAB software to stimulate all these simulations in the experiment. And lastly, we are also able to learn that the DC-DC boost converter is most suitable for usage in an automotive application, power amplifier applications, or battery power system. That's all from us. Thank you.